So welcome back to the channel. In this video we are going to study about the OSI model and how it works and how it goes. So what is OSI model? OSI model is like an open system interconnection which is followed in the network topology generally. And then what it does is like how the data moves from one device to another device step by step across the network. So on the left hand side you can see the 7-layer OSI model, which is called the physical data link network transport session layer, presentation layer, and application layer. So this is the 7-layer OSI model, but in the current era we are used to the new model that is called TCP IP model. So basically 5, 6, 7 layers are clubbed into one layer that is called application layer, and then we all use this 5 layers in all. So let's see what does the OSI model consist of. So physical layer basically consists of the physical cables like the manual hardcore wiring like fiber optics and RJ45, and the data type for it is like a bit. And then we have data link layer, mainly the MAC addressing takes place over here, where the switches are known for like the MAC addresses to flood the network, and then the data unit is frame. So going up network, so network layer is like an IP layer which consists of routers, and the data type would be packet. And in the transport layer, mostly the reliable transaction of the data is taking place, like with the protocols using TCP and UDP. And then the devices are like the terminology used in this is like port numbers, and then we have data type as segment. So basically you don't need to worry much about this because network engineers don't work mostly on the application layer. So just to give a quick pick, it's like session deals with the web browser, presentation deals with like the images and all, and the application deals with the like you basically the client and all. So that is clubbed into a data. So let's take a scenario or example how the network works. So imagine you are a client PC1 over here, and then with your web browser you want to ping www.google.com. So basically what the application layer first of all does, it reaches to the server. So client reaches to the server through the web server, and then it fetches some file from the web server. So coming to like application layer, so the web browser has been doing, and then on the 4th layer, so it finds out what at what port the web server is located and the file server is located. So it basically sees and what end-to-end communication, what port the communication to take place, like port 80 which is known as web server, and file server is on based port 21. So we'll cover the topics of the ports in later on in this channel. So coming down to the layer 3, which is like the IP transport layer. So once it knows the port, now it tries to find the IP of the server. So basically it knows like where the communication is going between whom and whom. So the PC and the server. So the PC's server's web IP is like 10.1.1.1, and then once it knows the IP address, the local network, that is the data link layer, the data is being transferred through the interfaces of the switches and the routers. So it comes to know about the MAC addresses of the PC's address on each devices on each interfaces. So it basically caches into it, and then there comes the hardcore physical layer, that is the electrical wiring and all. So the data is been transferred into bits. So yeah, that's what I basically told you. Like the physical layer sends the bit as a electrical and optical signal waves over physical medium. Local network, like the hop to hop delivery within the local network using MAC addresses and switches. So internet, what does internet do? It does an end-to-end communication between host using IP address and router. So coming to the transport layer, it provides end-to-end communication between the application process using port numbers. So port 80 and port 21, and the application layer protocol for communication between the application process, create and interpret. So that means the web browser pinging from the client to the server. So here's the thing. So now let's cover all the layers in details a bit. So layer 1 is a physical layer which sends and receives a bit as electrical or optical signal over a medium. So it's it consists of like copper UDP cables. Over here you can see fiber optic cables, the RJ45 cables over here, and then this ports are connected to like the NIC, that is called network interfaces card, or through which the network is being interfaced or accessed through the PCs, and then they are being communicated the data through the wire. So that's all for the layer 1. On the layer 2, as we have seen, it provides hop to hop delivery. That is means like one hop is like one step along the path between the two devices. So from one router or host, or like it can be from client to switch to router, and router to router, or like anything. So basic terminology used in the local network layer or data link layer is the MAC addresses. MAC addresses is used to identify the interfaces. So this interfaces should be when the PC1 transmits over here on this interface, it basically comes to know, this switch comes to know on this interface the PC1 is existing. So PC1 sends the message to the MAC address of R1's G1 interface. So this is G1 interface, and it comes it caches into the switch like the PC1 is over here, and so on and so along, like the R1 caches on the G1 and the server 1 caches on the G1 port. So the protocols included in this layer are Ethernet 802, like IEEE 802.3, and Wi-Fi. So yeah, that's about link layer. Layer 3, it's like a internet or like a IP layer, network layer, so in which the end-to-end delivery between the host across multiple networks is being carried. So it uses the IP address to identify the host in the network. So when PC1 sends a message to server 1, it addresses the message to server 1's IP addresses. So when it wants to send a message, it sends directly to a IP of this server. So router mainly operate in this layer, and in layer 2 switches operate in the main of that layer. So in this, the main protocol includes the IPv4 and IPv6. We will cover about IPv4 and v6 in the further topics. And then ICMP. ICMP is nothing but the pinging, like just to check the connectivity, like whether you are able to ping successfully the other client or no. So the ICMP comes under this layer 3 protocol. So on layer 4, as I said, most of the time the communication between the application process takes place, so which is done with the help of the port numbers. And when the web client on the PC1 wants to send a request to the web server, it addresses the message to port 80. So yeah, and basically two main protocols work in this layer, that is TCP and UDP. So TCP is a reliable protocol in which the no loss of messages takes place, or like even the loss of messages takes place if the retransmission takes place. And UDP is called the user datagram protocol, which is like a fast and efficient thing, but a bit unreliable. Okay, so coming to layer 5, which is a combination of layer 5, 6 and 7 combined together, in which it defines how application process, format, send and interpret data. So protocol at this layer defines the HTTP or HTTPS, like the web application, as I said, images and all, and to transfer the images, the file transfer protocol TFTP takes place, and so on so along. So network infrastructure devices, routers and switches do not care about the application layer details. So that's why I told you the network engineer do not depend like work more on layer 5, 6 and 7. mostly the layers we deal with is like the first 4 layers. So they just move messages across the network, and only communicating host interprets the data. So that's all we need to care about layer 1, 2, 3, 4. So web's application layer is just on the client layer. So let's just see in depth how the encapsulation and decapsulation takes place. So at first, at the application layer, we have the data. So this is called packet data unit, or the PDU, the terminology being used. So we'll cover terminology in some minute. And then so how, like, once from the layer 5, it's encapsulated with layer 4 header on layer 4, and then again it encapsulates with header 3 on the layer 3, and then on the layer 2 it encapsulates with layer 2 header and layer 2 trailer, and then all this frame all this thing is being sent over the physical layer through the physical medium in terms of bytes. So as I told you, application layer prepares the data, and then it moves on to the stack, encapsulating the headers, and then with the port numbers, IP and MAC addresses respectively in layer 4, 3 and 2, and then layer 1 transmits the bits as a signal over a physical medium. So this is how the encapsulation takes place, and let's say the PC1 sends from one part to the second PC. So basically in the reverse order the decapsulation takes place, like the layer 2 is decapsulated, layer 3 will be decapsulated, and layer 4, and then at last at the application layer the PC2 will get the contents of the data. So let's see, at each stage in encapsulation or decapsulation process there is a name given to the message. So the combination of layer 4 header is called segment for TCP and datagram for UDP. So TCP creates segment and UDP creates datagram. So this is a terminology which is being used at layer 4. So for TCP, remember segment, and UDP is datagram. Further, the combination of segment and datagram with layer 3 header is called packet, and then further the combination of layer 2, layer 3, layer 4 and layer data is called a frame, which is actually sent over the data wire. And then we can use alternative names describing the messages at each stage, that is called protocol data unit, my bad. So at layer 2, at layer 4 it's called layer 4 PDU, layer 3 packet, L3 PDU, and frame is called L2 PDU. So basically, and below this it's bits. So as it is passed over the wire, so it's called bits, frame, packet and segment or datagram. So the contents of each PDU are called, so whatever the content like the each layer has is called the payload. So basically a segment or a datagram payload in its application is the application data. In layer 4 the content is like data. In layer 3 the content is layer 4 plus data, and in frame layer 3, layer 4 header and layer data is called the payload in layer 2. Okay, so basically this is all the OSI model, and then in general practice we follow the TCP IP model, which is being combination of 5, 6, 7 layer. So basically we don't, network engineers really don't deal with the application layer, they mostly deal with all these 4 layers. So basically this is all for the OSI model we have learned, and this is all for the video. Hope you understood the concepts. If you have any doubts, ping in the comments, like, share and subscribe. Thank you.